Hi, so my name is Satyam and this is day 4 of my interview prep journey. In this video, we will solve problem around binary tree. So the problem called all tree paths. Okay, so first let's understand about the problem. We need to write a function called all three parts that takes in the root of a binary tree. The functions will return a two-dimensional array where each subarray represents a root to leaf path in the tree. The order within an individual path must start at the root and end at the leaf. But the relative order among paths in the order array does not matter. You may assume that the input is not empty. So basically, we need to get the all path tree in the array, right? So for example, this is our binary tree. So the output will be uh, all the path uh, which are from root to leaf, right? So for example, abd is a 1, abe is 1, acf is again, right? So let's take a smaller tree. For example, a okay, it has b and c. Okay, so we need to return uh, array containing different paths on this array containing all the paths in a tree where subarray contains a path, right? So a b and this will be a c, right? So how can we solve this? Okay, so because we are working with binary tree and also we are finding paths and all, right? So the best way of solving this by depth first recursion, right? So we will use recursion for solving this problem. And so what are the base cases for this, right? So because we need to get to the leaf node, right? So first base case will be, or one base case will be a leaf node, right? Which is right and left node are null, right? And second, we need to be um, let's say if we reach leaf node, what's what should we return actually, right? So we can return array with subarray with um, with its value, node value, right? Let's say, okay. Why sub array? Why cannot I just return value, or just array containing value, right? Because at the end we need to return array containing sub arrays, right? So with that respect, right, we need to be consistent uh, with our result, because we are working with recursion, right? So let's try to imagine this tree and think how can we solve this by recursion. Okay, so we have reached here, okay, b and c. So this should be b and this should be c. So now how can we um, make this to this array, right, that we want? So we will go, because it is recursion, right? So it will go up, right, to the root of a node, to the node, to the parent node basically. So it will go here. What we really want to do is basically basically merge this, or concat this concat uh, these array in one array, right? So if I concat this array, this should be b c, right? So after converting into a single array, what we really want to do is just um, add our um, parent node value, right? So I can add here, I can add here. So this is simple. So this is the solution that we want, or this is the output that we want. So I think we have solved, or we have discussed how can we approach this, right? So let's translate this to our code. Okay, so we know there will be one edge case, or not edge case. Okay, so let's say if, okay, so we have not discussed if our root is null. Okay, so what should we return actually? We can return empty array. Okay, uh, because if we return null, if we concat in a single array, it should be the null will be there. So empty array, if I um, have empty array, if I merge into a single array, the empty array won't be a pair, won't be there, right? So it should be only one um, sub array. Okay, so we can do that. If root equal null, we can return empty array, right? Now if if our root is leaf node, uh, root dot left equal to null, and root dot right equal to null, we can return array with subarray with the value. Okay, this looks fine. Now we call the right path or left path, right? All three paths with root dot left, same for right path. Okay, so now we need to concatenate, add uh, element to the to its subarray, right, to its path which it belongs, right? So how can we do this, right? Because we need to have a single array, right? So what I can do is create our results array. Okay, and okay, hmm, I can loop over our left path. Value of left path, what I can do is add current root dot value to the left path, right? Because here we discuss that we are adding here, right, to each to its subarray. So I can maybe path dot push root dot val, right? Then I can just push this subarray into our results, right? Path push path. Now we can do same for the right path. Now we can just return results here. This looks fine, right? It has we are looping or we pushing to a single array here will and we are returning the results. Okay, now test it and check where we are. Okay, so we are returning in this like array sub array, but the placement is not the same, right? Because a b, because it looks like it is reverse, right? So we need to reverse our array. Okay, I mean there can be multiple ways, but if I talk about optimized way to do, right, we don't need to like touch here anything, because if we do the time complexity would be o n square, because in each function call we need, then we are doing some modification, right? So this we don't want to do. So what we can do is edit this function to, let's say, helper, right, like this, and this function will call the helper function. Okay, and this looks fine. Now I can reverse here, because if we reverse here, um, I, so the time complexity would be o n square or more than that. If we did here, it should be o n plus n, right? If we simplify this, this should be o n, because we are reverse, because we are doing all the modifications that we want in one uh, at once only, right? After we have done all the after we get all the result, right? So can just reverse this result dot reverse and return our results. This looks fine. I think I need to change this to here, because it will call this function. Now test it. Okay, so we have completed this task. Thank you for watching the video. Bye bye.